Let's suppose I'm a developer and I want to deploy my application to the Azure cloud that my company has set up for the entire enterprise, right? Look, it's always quite difficult for me to understand what kind of infrastructure do I have the permission to deploy my infrastructure in a manner in which it is compliant to all the requirements that my enterprise has set up in terms of security and others. And I'm just a JavaScript or Java developer. I don't have the time to learn about Azure, bicep, Azure virtual machines, all the services that are available on Azure, right? And I usually need to rely on our DevOps team for that, right? But thanks to GitHub Copilot and to Azure Dev Centers, this can change. And I can do all of that by myself thanks to Copilot, right? So let's have a look at that. First of all, I want to show you what a Dev Center looks like on Azure. So if we look at a Dev Center on Azure, this is how it looks like. We can see the name of the Dev Center, which I have called TestDB Center. And this will be a Dev Center set up by our platform engineering team, or initially our DevOps team, with a catalog or a set of catalogs attached, which will contain templates, definitions of infrastructure which can be deployed to the Azure cloud. So it's ready to use Azure resource templates, which we call Azure Deployment Environment definitions, for our developers to quickly set up environments, deployment environments, right? Here we can see there are some templates available in the catalog. The catalog is stored in a GitHub repository. And furthermore, the platform engineers can set up different environment types like development, test, production, right? Which they can then configure with different set of permissions, roles, and so on. And they can define projects like this one, Oracle ERP Devs, right? Projects mimic business units or teams which have access to different environment types. So let's now have a look at how I can use all these concepts from Visual Studio Code and using GitHub Copilot to deploy a Java application, right? So GitHub Copilot has just released a feature which is a game changer, and that's the agent mode, the agent capability. Thanks to Visual Studio Code and the reusable prompts functionality, which I invite you to have a look at in the documentation, the platform engineering team can not only define this dev center and all the definitions of environments and so on, but they can also potentially pre-write, pre-bake a script in the form of a prompt for the GitHub Copilot agent to go through and help developers to choose a definition of an Azure deployment environment, choose the right one for their application, and then set up a GitHub Actions workflow to deploy to that new environment, right? So that way, I as a developer, I can be much more autonomous and using Copilot, do everything I need to create my environment and to link my application source code to that environment and set up a pipeline to deploy to it. Let's have a look at how that looks like from Visual Studio Code. So first of all, I pass in the reusable prompt to the agent like that. And then GitHub Copilot reads all those instructions in the prompt and starts asking me for the first step, some details, right? Like what's the repository name? What's the environment type that you want to deploy? And what's the kind of workload, right? And all these, all this information will allow the GitHub Copilot agent to look for the right Azure Deployment Environments or ADE definitions in the catalog, right? Remember the catalog I showed you before. So now, thanks to that data, it's going to look like, it's going to look for ADE definitions, right? And here it's using an MCP server, that I have implemented, which is exposing some very useful tools for this scenario. In this case, searching for ADE definitions. So now the GitHub Copilot agent retrieves a list of definitions available in the catalog and tells me that there is one which looks quite compatible with my application, and it's called web app. All right, and this definition deploys an Azure web app without a data store, which looks like could work for the application. I'd say, yeah, sounds good. Let's go ahead with that. And GitHub Copilot will progress looking at that reusable prompt, right? That reusable prompt contains all the steps, and then it goes into obtaining additional details about that particular ADE definition to understand how to create an environment based on that template, right? And that's what it does here. It calls the MCP server tool create ADE environment. This takes actually several minutes to complete, so I have speed up the video here, not to make you wait, but it's the perfect time to go for a coffee, right? And once that ADE environment is deployed, let's see what it does. It's going to inspect it. It's going to inspect which resources have been effectively deployed under that deployment environment, right? To understand what has been done. Okay, and it says, yeah, I can see that in the environment we have an Azure App Service Plan and an Azure Web App, right? Let's have a look on the Azure portal, whether that's true, right? I open the Dev Center project, the environments, and I have that environment there with the 2 Azure resources deployed. So that's great. And furthermore, what's doing here, it's analyzing my project and telling me this is a Java Spring Boot web application that you are working with. Looks like it's meant to run on Windows servers because there is a web config file. Perfect. And it's going to check the compatibility between what's been deployed in the environment in terms of infrastructure and my application, and see whether there is any mismatch to basically fix those mismatches and ensure that the deployment can happen and can work correctly, right? And it's telling me, okay, well, this project of yours runs on Java 17 and on Windows, correct? So it's coming up with a plan, with a strategy to make sure that this can be deployed using GitHub Actions, saying, yeah, I will use OIDC for secure authentication to Azure in the pipeline. I will include the jar and the web config file in the deployment to make sure it works because this is meant to run on Windows. And I just want to make sure that it will also check that Java 17 is effectively running on that Azure web app service on the Azure portal, right? Which will ensure that we have the appropriate JDK, and we'll just make sure the agent understands that I want to use Ubuntu runners on GitHub Actions. I don't want to deal with the complexity of Windows runners in this case because I'm not used to that. So I just add some additional instructions on top of that standard reusable prompt, and then the agent goes into inspecting the resources again. Yeah, right. So it's going to check whether JDK 17 is running on the Azure app server. And it says, hey, we need to configure the Java runtime settings. And it gives me a command that it will run on the terminal to make sure that we have the appropriate JDK. So I just run it, and this is part of that compatibility check between the infrastructure that's been deployed on the AD environment and my application, right? So in this case, there is this command to run to make sure that the deployment will work. And then it's checking whether I have any GitHub Actions workflow already in my folder to reuse, or to understand how I'm building my application in case we have already one pipeline. And then it comes and generates completely the deployment workflow on GitHub Actions. This is looking good. It's logging into Azure with the right Azure GitHub action with OIDC. And it's asking me whether I want to adjust the plan on how to configure all this, right? Whether I want to modify deployment strategy or anything, or add additional protection rules to a GitHub environment, which I don't have. I say, no, look, this is great. progress, please, with this OIDC setup. And the agent continues its task, right? And it's going to create an Entra application and service principal on Azure to basically start configuring that OIDC authentication between my GitHub Actions workflow and the Azure resource group, which contains the resources of my ADE environment. So that's being done with, again, an MCP server tool that I have implemented, just to make sure that these steps are standardized, are easy for the agent to pick up and to execute in a secure manner. And then it's asking for the GitHub organization name, which is going to recover autonomously with this git command in order to create the federated credential. And the federated credential, the claim, has to contain that organization name. This is for OIDC to work. OIDC is a great protocol in order to authenticate GitHub Actions workflow securely, right? I won't go into details there, but it's doing all of that for me. It's a little bit complex, but it's abstracting me or really letting me have an easier time around that complexity thanks to the reusable prompt and these MCP server tools. It has created the federated credential, and it has also created a GitHub environment in my repository called test, right? Which is exactly the same name as the ADE environment type that I have chosen at the beginning, right? And then it's starting to populate this GitHub environment with secrets, right? With secrets, which we can see there in the pipeline, the Azure Client ID, the Azure Tenant ID, and the Azure Subscription ID. Those are secrets needed for logging into Azure, right? And being able to authenticate with OIDC. And it's asking me to provide the Tenant ID and Subscription ID, which it cannot recover. I'm just going to copy paste the tenant ID, which I have in my MCP server configuration settings. Right? I could ask a colleague, I could check on my files and simply give the information to the agent, right? That's the beauty of the agentic workflow. Whenever it can use an available MCP server tool, it will use it. Whenever it needs to validate something with the user, it will do that. And whenever it needs extra information from me, it will ask me for that, right? With the human in the loop. It continues populating the GitHub environment with the secrets needed. Let's just accept, right? And I expect that once the GitHub environment is filled up with all those secrets, potentially we can push this pipeline and have our application deployed to Azure. And there we have the 3 secrets populated. I have not had to, break my flow, go to github.com, start figuring out, oh, I need to create a GitHub environment. Oh, I need to populate it with secrets. How do I make the connection with this ADE environment that my platform engineering team has put up for me, right? The agent is taking care of all that complexity and just letting me go with the flow and have an easy time with the deployment, right? Here we have the pipeline running after the push. It's authenticated with Azure successfully with OIDC, as we can see there. I have sped up that pipeline. And finally, here we have the deployment. Hello, Agentic world. So it's worked. The application, the Java application, has been deployed to the Azure web service. And I think, I hope that with this demo, you've seen what are the amazing opportunities that GitHub Copilot agent mode is opening up for us. I hope that you have also realized how Azure Dev Centers really have an amazing potential for platform engineering teams and non-existent platform engineering teams to be created, right? Because this is really a very powerful concept and service from Azure to help enterprises standardize deployments, standardize security, make sure compliance is there, and put all that together for developers to have a much easier time self-serving everything through Copilot and basically, enjoying coding much more. So thank you for watching. I hope you have liked it and don't hesitate to share feedback. Bye-bye.